Subject code 18CS2015 Object Oriented Programming Lab Experiment number 6 Abstract Class and Interface. In this video, we are going to see how interface concept can be implemented in Java programming language. So here is a basic program which is like just like a student portal where the student is prompted to, where the student is given all these options like to calculate his academic credit, to register any subject, to assign a faculty for the respective subject, and this is for student academics. Uh, on the side, when it comes to non-academics part of a student, these are the methods, these are the options he has to calculate non-academic credit, or to register any club under non-academics area. So uh, after that, so we need to declare all these methods. Just to declare them, do not write any implementation part in inside these interfaces. So first we have to create an interface called academics with all the required methods for academics of a student. So after that we have another interface saying non-academics, which have methods that are of non-academic requirement of a student. So after that we have an abstract class codes, which is to uh, read the assign all the name and roll number of students using the constructors. We use this abstract class course, and also we have an array list for subjects, faculty, and club. This is available in the util package of Java util package. Since we have imported this above, we can use this array list. We are creating an object for this array list. uh, this is the reference of our object subject list, and the next one is faculty list and the club list. So these lists can be added with any kind of data. So these three are lists, and after that we have in integer type data, that is credits and non-academic credits, which have to be calculated. So after that we are using a scanner object here in this abstract class. This is the data member which can be shared across, shared among the child classes which inherit this course. So all these are these data members of this course class, and also we have a default constructor, and we have name, register number, and non-academic club name as under string data type, and we are using this parameterized constructor with two variables to initialize a name and register number. Each time when we create an object for this child class, this superclass constructor will be invoked, and his name and register number will be initialized automatically. And after that we have a student, we have two kinds of students here, which student one extends course and implements academics. Means academics, a student related to academics, and students non-academics part also. So here we can see student 2 extends course and implements non-academics. So first we'll see this first student, that is academics part of a student. So his name and register number will be passed when we create an object for this child class, and those values will be passed to the superclass constructor using this super keyword. And after that we have we are implementing the methods which we have declared in the interface above, academics interface above. So one of those methods is calculate uh, academic credit. So for example, 3 credits for, if we assume 3 credits for subject, for any subject, so that many credits will be given to the student. So that's the logic, 3 into number of subjects. So we are passing a parameter to this method, number of subjects, we are multiplying it with 3, and that will be stored in credits. And after that, register subject. So before that we have to take the number of subjects to be registered, and we are using a loop, and so that we will be adding that subjects to this subjects list which I have shown above each time in each iteration. That's it about register subject. And after that we are same logic we are using for assign faculty also. If subjects list size 0, that means if there is any, if there is no subject registered so far, so there is no need of faculty, right? So that's subject list size 0, then no subjects registered for faculty selection. Otherwise, if there are any subjects, then we can ask the student to register faculty for that particular subject. So here is a loop, uh, and each time we are asking user to enter faculty name for the subject. So subject list dot get of j, that means the uh, 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 j means this is the index, right? So subject list dot get of j means subject list, the first uh, uh, I mean the first data will be displayed here. First data using this index operator, that is j, and in each iteration will be asked enter faculty name for the subject 1, subject 2, like that. And each time when the student enters any faculty name, that name will be added to faculty list. That's it. That's about assign faculty. Now in each student, for each student there is a display function which just prints the name, register number entered by the student, and subject registered by the student, and faculty assigned for each subject. That's that is done by the display method. Now the same thing uh, applies for the student 2 also, which implements non-academics. That means we're implementing only methods of non-academic interface in this student 2 class. So this is the parameterized constructor, right? So we are passing the this name and roll number to the superclass constructor. And register club for this non-academics takes number of clubs to be registered, and we use a for loop under that range, and enter club activity 1, and we will take that in input into the club list, where we're taking that input using the scanner object next method, and adding that club name to this club list. That's it about register club and calculate non-academic credit. Since the in the question that nothing was mentioned based on this and that, what I have took is just uh, uh, we will print the name, register number, and clubs registered. That's it. That means number of clubs registered, that is under display function. And non-academic credits is for each club we assume that there is a credit of three credits. So club list dot size into 3 multiplied with 3 can be considered as non-academic credits. That's it. And after that, display function just displays the name and register number, clubs registered, if any. That's it about a display function of second student. So we are implementing all these methods using a class interface class below with main function. So here is a menu for the user to choose between academics and non-academics. So if the user presses 1, it has to show the it has to call the create an object for the student 1, or else we will create an object for student 2. Using that object, we have to call this corresponding method, that is subject uh, academic credit calculation, assign faculty, and display method. Same thing applies for this second student also, non-academics part of the student also. Name, register number, we are prompting the user to enter, and assigning that to name string uh, using this next method of scanner object. So enter number of club activities to register for, and after that we are calculating the academic credit based on those club activities. And after once all these operations are done, we are displaying each time for each student. Now we'll run this and check if it's working perfectly or not. Just a minute. Yeah. For example, when you press 1, that is for academics, we will be prompted to enter the name. For example, if the name is Andy, and register number is 1 2 3 4 5 6, number of subjects if it is 2, subject 1 mass, subjects, and the faculty name for subject mass, we see ABC. For physics we'll say DEF. And yeah, we can see the display method here: name Sandy, register number, subjects registered, the mass physics, faculty selected, mass ABC. For physics it is DEF, and total credits is 6 because there are 2 subjects registered. That is for academics. Now we'll check for non-academics also. Enter name Sandy, register number 1 2 3 4 5, number of club activities to register for 2. uh, One is hacking club, second one if it is IoT. Yeah, we can see the details: name, register number, club registered, 2 clubs. So now we'll see our second program interface, that is to operate all the mathematical operations to like addition, subtraction, and under basic operations, I mean arithmetic operations, and sine, cosine, and tan values under trigonometric operations. So for that we are creating an two interfaces with for one is for basic arithmetic operations, and second one is for trigonometric operations. So these are the methods under basic arithmetic operations, that is add, subtraction, multiplication, division, and modulus operation. And under trigonometric operations, we have sine, cosine, and tan calculations. And after that, we have abstract class calculator class, which is to initialize the values. That means the numbers, to initialize the numbers, we have constructors under this class to initialize the values. That's it. So here is a scanner class to read the input from the user, and these are the variables which I have declared under double data type. So this is the default constructor of this class, calculator, and in which we are prompting the user to enter number 1 and number 2, and we are assigning I mean num1 and num2 to this data members, num1 and num2. Since when we inherit any uh, when we use any inheritance concept, and when we have any child class for this calculator, so these data members will be shared among them also. Now here we have a parameterized constructor. We'll see how and why. So here is our child class operation, that is that inherits a calculator as a superclass and implements maths operable and trigonometric operable. So here is our default constructor of this class, which is calling the default constructor of superclass, and operation is a parameterized constructor. So which calls a parameterized constructor of the superclass, and in that we are implementing add function of basic arithmetic operations. We're implementing here, which is just to add the both numbers, right? So that one we are storing under result. So here we can see subtraction method. Here we can see multiplication method, which has been implemented, and after that we can see division method. Same is the case with modulus operation, and we have implemented a sine function. To do that, we are converting uh, the user entered value to radians using a 2 radians method from under math module, and passing that to the sine function under math module, so that the result will be assigned with the correct appropriate sine value. And after that, we are converting I mean we have implemented cosine value also, cosine method also, and tan method also. After that, we have I think okay. Each time we create we call this method, the result of this parent class will be updated with the calculated result. So all these classes we are operating through this main class, that is interface 2, which has a main method in it, and which has infinite value also. Here is an infinite value, which prompts the user to enter 1 for arithmetic operations, 2 for trigonometric operations, and 3 to exit. So we are creating an object for this I mean reading the input from this from the user, right? So if the user presses 1, uh, we have another infinite value uh, for these operations, that I mean addition, subtraction, multiplication, and division, those operations. And once this value is exited, will be again will be uh, again given these options, arithmetic operation and trigonometric operations. So for that, we are prompting the user to enter 6 to break this loop, or else print an invalid input for any other input. We'll see if the user presses 1. We are creating an object for this operation class, and using that object we are calling the add method. After once we call the add method, the result will be updated, right? So using the same object, we are calling the result variable of the parent class, right? I mean the object class, right? So we are using that object one dot result, that will be the sum. And same is the case with all these methods. And after that, if the user presses 2, that is for trigonometric operations. uh, Same is the case. We are prompting the user to enter value in degrees. Once he enters the value, we are passing that value through this object, and in the same object we are calling the sine method. uh, After that, with the same object we are printing the result of the parent class, that is the sine value. And the same is the case with all the sine three operations, that is sine, cosine, and tan. If the choice is 4, we are breaking this while loop, or else we'll print invalid input for any other inputs. Or else if the choice is 3, we are breaking the That's it. We'll check this whether if it's working perfectly or not. Yeah, we can see the menu: arithmetic operations, trigonometric operations, and 3 to exit. First, we'll try with arithmetic operations. We'll try subtraction. Number 1 is 10, number 2 is 5. So we can see the difference is 5. So we'll exit from this menu. We'll be given this menu, and once we now we'll check for trigonometric operations 2. We'll check cosine, cos uh, 0 0 degrees. Yeah, we can see cosine of 0 degrees is 1. We'll check 3, but tan of 45 degrees is 1, right? So we can see 0. Approximate value. Now once we exit from this menu, we'll be given prompted this menu, and once we press exit at here 3, that's it, our program will be finished. Now the third program is based on packages in Java. So here we have a basic program to demonstrate packages concept in Java. So the same uh, arithmetic and trigonometric operations we are performing on this we are performing to demonstrate this package concept in Java. So first we have here, we totally have 3 files here. First one is basic operations and second one is trigonometric operations. These two are under mathematics package, you can see, and this test.java is under mypack package. So we're going to be use some import functions to and operating these methods in another package. So first we have to define a package mathematics, and we are using a scanner class, and this file has, I mean this package has some methods. Under the basic operation class we have some methods, that is add method, subtraction method, multiplication, division, and modulus method, which prompt the user to enter the number and result return the appropriate calculated value. I mean if it is addition, we are returning num1 plus num2, num1 minus num2 for subtraction, in that way. So that is about the first mathematics package. That's it, and we'll see the next uh, class under this package. Second class in the mathematics package is trigonometric operations, which has the same standard class again, and we are prompting the user to enter value in degrees, and we are returning the calculated sine value if it is under the sine method, and calculated cosine value under the cosine method, calculated tan value under the tan method. That's it about the second class under mathematics package. Now test.java, in this from this uh, mypack package, we are going to operate all these functions, I mean the add function, sine function, all these functions of other packages in this package. So that's why we are importing uh, here we can see import mathematics dot basic op. That means the basic operation is a class, and this is the package mathematics package dot class name. So here the same case mathematics class, and trigonometric operation is the class, or else we can follow this, right, like this also, mathematics for star. So this is also enough. This will import all the classes and under this under that package. So to demonstrate clearly, I have written like this: package name dot the first class, package name dot the second class. So from this test class, I mean of another package, that is my pack, we are implementing this program. So under the main function, we are creating an object for this these two classes of another package. Since we have imported the the classes, we are able to create this object for the classes now. So once we create an object for these classes, we have an infinite while loop to display this menu to the user, which says select your choice: 1 for basic arithmetic operations, 2 for trigonometric operations, 3 to exit. So if the user prefers one, then and we have another infinite while loop. So and to display this menu: 1 for addition, 2 subtraction, and 5 for modulus, and 6 to exit. So if the user presses 1, then we are calling the object add method of under the object one is the object of this basic operation class, right? So basic operations have this method add. So using that object, we are calling add method. So once the value is written, we are storing the value in the returned value, and we are printing addition is the nothing but the value written by this method. So the same is the case with all these methods: addition, subtraction, multiplication, division, and modulus function. uh, Otherwise, if the user presses 6, we are simply breaking the loop that to terminate our execution. And after that, if the choice is if it is for trigonometric operations, we are displaying this menu using another infinite while loop. And if the choice is 1, we are calling the sign method under the trigonometric operation uh, class using the object 2. That object 2 is the object of trigonometric operation class. So using that object we are calling sign method, and whatever it is written, that returned value we are printing sign value. And same is the case with cosine and tan also. And if the user presses 3, we are simply breaking the uh, inner while loop. And once this user presses 3, that means that he wants to exit from the program. So we are breaking the outer while loop. So here this is our outer while loop. We are breaking that if the user presses 3. That's it. Our program will be finished. Now we'll check if this is working perfectly or not. Let's load main. Uh, One for basic operation, arithmetic operations. We'll try one first. We'll try for multiplication 20. We can see multiplication of 10 and 20 is 200. And when we exit from this menu, we'll be displayed this menu. And when we check for trigonometric operations, we check for 1 sine 0 0. It returns 0, right? So that's it. When we press 4 to exit, will be displayed this menu. And when we press 3, the program will be finished. That's it. I hope all the programs have been executed successfully, and the outputs for all the given inputs are correct. Thank you.